In this video, we're going to learn how to use our TI-84 calculator in order to calculate probabilities associated with normal random variables. Now, anytime we're going to ask you to do this, we have to give you the mean and standard deviation of our normal random variable. Otherwise, it's going to be impossible to find. So you can expect to be given that. Then we're going to ask you to find this probability. In this case, I want the values of x between 80 and 90. So what I always start out with, I draw a little picture here to see what it is we are talking about. So we have a normal random variable, looks something like this. 85 is our mean, and we want to find the area or the probability that's between 80 and 90. So now that we see what we're looking for, let's pull up our calculator here. Remember that the mean is 85. Standard deviation is 4, and we want to go between 80 and 90. Now, in order to do this, anytime you want to find areas involving normal distributions, you're going to hit the second key and then the vars key. That brings up the distributions menu. And again, there's a lot of different things here. We're going to use most of them. Right now, though, we're going to use normal CDF. I do want to caution you, do not use normal PDF for this, the top choice. In fact, we will never use normal PDF in here. So go to the normal CDF, hit enter, and it's going to ask you for 4 things. It asks you for the lower part of your area, the upper part of your area, the mean, and the standard deviation. I'm going to scroll down and actually I'll leave it. So it was from 80 to 90. That's the part of our area we're looking for, lower and upper. The mean is 85. Standard deviation is 4. All you do is you hit those 4 numbers in there, hit enter, and we get 0.7887. So if I go ahead and copy that over here, 0.7887, that is going to be our area. So now we know there's a little under 80% chance that the x value is going to be between 80 and 90. Now for my second example here, I see that I have the same mean of 85 and standard deviation of 4, make our life a little bit easier. But now I want to find the probability that x is bigger than 92. So that means I want all the things from 92 all the way to the right. So the lower bound, the lower part of my area is 92, but the upper part of the area, there is no upper part. It's going to keep going on forever. So that basically means infinity. However, when I go to put it into my calculator, and I go second vars, normal CDF, I am starting here at 92, and I want to go on to infinity. There is no infinity button on our calculator here, so we're just going to hit a bunch of 9s to indicate it's a really big number, and then hit paste. And so this time we get 0400, so that's basically 4%. And that would be the probability that we're looking for here. So whenever you're trying to go all the way out to one side, you should be putting something like infinity in there. Since there's not actually an infinity key, just pick some large number and you're fine. On the other hand, on this one, I want the probability that starts at 92, but everything below it. I want everything below 92. So that means now 92 is my upper part of my area, and the lower part is all the way to the left. It's kind of infinity, but it wouldn't be infinity. It'd be negative infinity. And so when I go to put that in my calculator again, second vars, normal CDF, my lower now is going to be negative infinity, so hit the negative key. And it's important, I'll clear that out, you need to hit the negative key, not the minus key. They are 2 different keys here. You hit the negative first, put a bunch of 9s. Then go to 92. We kept the mean and standard deviation the same. And this time we get 0.9599. So we get 0.9599 here. That is going to be the area that we're looking for. And by the way, we could have done this a different way. This is going to be the complement of the part to the right of 92. So we could have done 1 minus the 0.04 from before, from complements. And you see, we didn't get the exact same thing. It's because some rounding errors there. But regardless, it's essentially the same answer. We could have used the complement rule, but it's important to know both ways how to put it in your calculator.